Today we'll make a brand new project from start to finish. We'll take an ESP32 microcontroller and use it to monitor some different temperatures and display them out to a web page we can view on our phone without internet anywhere. We can use these values to tune internal combustion engines or monitor temperature in anything we wish, from low temperatures to very, very high. Here on this channel, we've made a ton of different projects over the years, and we've made a few web-based projects, ESP8266 and ESP32 projects. Well, today's project is a little different. As many of you know, I work with power tools a fair bit in my spare time. I actually enjoy working with chainsaws, my four-wheeler, getting into the outdoors, but tuning power tools, well, that's a little bit of an art in itself, and I've always wanted to have a tool, a measurement tool to monitor exhaust gas temperatures of internal combustion engines while we're tuning them and even just monitoring them. Well, today we're going to take an ESP32 and use that to actually make a thermocouple to read the exhaust gas temperature from these small engines. These chainsaws are fantastic to tune when you can monitor EGT. You can get a little bit more power without a lot of risk that way. Pretty cool. The process to tune the engine is actually just the process of removing or adding fuel till you get maximum amount of power without burning the thing up. Well, that's what we'll do today. Parts we'll use for this project: an ESP32 Wi-Fi microcontroller, a custom PCB we'll make today, a high temp thermocouple, and a temperature and pressure sensor. So what I did is I took the ESP32 and set it up in a breadboard with thermocouple and our BME 280 sensor here, which I actually used a BMP 280 as well, and I've done two different versions of it. And this system surprised me how well it actually works. It works quite wonderful to broadcast out a live display of both sensors on a web page, and I've modified the web page slightly from the previous examples I found online, and it seems to work good with asynchronous data transmission, and everything just does as I wanted to. So it's time to move into another phase of this project and make something a little bit more permanent. Now we'll use the ESP32 microcontroller pictured here. My GitHub is linked down below with all this information. The problem I ran into right away is that the Wemos 32 Lowland Light board didn't have a footprint and schematic setup that I could use easily in KiCad in my drawing program to make the circuit board. So I ended up having to have this made. I tried converting it and I failed miserably, so I ended up going to Fiverr.com and having somebody make one for me. I've shared it in my GitHub for you, so you don't have to have one made yourself, no problem. Since we already had the prototype in the breadboard, it was pretty easy to make up a schematic in KiCad. This is an open source program you can download for your schematics and making boards and exporting the Gerber files to have the PCBs made. It's a pretty cool program. I'm really happy with it. It's easy to use. Just use some global labels around, set things up. Circuit this simple is pretty straightforward. Just run the global labels out to our different components, which is basically our pressure sensor, our thermocouple, and an optional switch. Not much to it from the ESP32. Once the schematic is done, we move over to the board layout view. This is a rat's nest view. You'll see these small lines. They're indicating that that's where you have a schematic connection on your schematic, and you need to actually route a copper trace. So I just route the copper traces around, super simple on this board. The signals we're dealing with here are not very sensitive. We don't have to worry about trace lengths or any interference really at all. These are pretty straightforward things. So just route them however you see fit on the board. We add our copper and ground fills, and that's it. Our board is ready for manufacturing. Always a good idea at this stage to give your board a look over. The 3D viewer makes this really easy. In this case, I've used male headers. That's not what will actually be installed, but spacing is the same, holes are the same. It gives us a good look at the board, make sure everything is going to be the way it needs to be, and from here we can also print out a copy of this on plain paper and check it in our enclosure. Now we head to PCBWay.com where we can order our boards for manufacture. Before we upload anything, we select all the options we want. We want to panelize these with 2 per panel so we can get a few more boards at a pretty reduced price. We want to check our layers, which is 2-layer board in our case. We want to check what coatings we want, what color of boards we want. There's different pricings for each, but the defaults on just about everything will be fine. And if there's a problem, PCBWay will let you know. Just keep an eye on the pricing on the right-hand side and see whether it suits your project and pick what you like. Now we can use their online Gerber viewer to actually look at the Gerber files we've generated and make sure they actually look like the board that we want to have made. Looking at the top and bottom, you can get a pretty good idea exactly how your boards are going to come out. Looks great. With the boards ordered, we can go into Fusion 360 and use the existing project case that I've used over and over and over again here. All the files are linked down below in GitHub. This is a parameterized model that you just input the different dimensions. Thank you, Noe and Pedro, for the awesome videos from Adafruit that taught me how to do this. I just added some standoffs on the bottom by editing the sketch and added a cutout for the USB. I didn't do a very good job. This may or may not work, as we find out later. It needs some iterations, but off to the 3D printer and we can slice it up. We use a program called Cura to actually slice the model into G-code that the printer can understand. Nothing to it. This gives us another chance to have a good look at our model and make sure that our dimensions have been maintained, which they seem to be here because it physically looks right on the bed. We send it to the printer and print it. A Christmas in summer package arrives. I always love how they reuse their Christmas wrapping. The boards arrive from PCBWay via DHL post. Super fast as always. Come in this nifty little shrink wrap that seems to protect them really well. Gave me a pen, and I just love how these look out. This is just the best part of electronics for me lately is when I get a board that I've designed, and this is nothing special, this board. It's just a place to mount things. There's not a lot of components on it, but I'm pretty happy with the way it turned out because it's mine. Next up, one of my favorite parts of any project is actually assembling the first boards and debugging them and seeing if everything fits as I intended it to. It's a little bit of fun. I enjoy soldering. That's why I like this hobby. So a simple project like this, pretty easy for anyone to put together. I'll put kits down below and on my store for this so that others can maybe enjoy building these as well. I had to do a little bit of debugging here because the sensors I ended up with BME 280s arrived as BMP 280s, which don't have humidity reading. So I had to go through and rewrite my code, which was a blessing in disguise. I ended up with 2 versions of the code now, depending on what hardware you want to buy. The BME 280s can be a little bit expensive, where the BMPs are only $1 or so when you buy them in quantity. So I figured, well, now we have multiple options and we have a PCB. Altogether, it looks pretty good. My case doesn't fit just perfect. It needs some work, but this is something we can work with and get started. We can get this out into the field and test it out and make sure that the hardware actually does what we intended to do, and what happened on the breadboard is repeatable on the new printed circuit board. Quick test of the actual hardware, and sure enough, we're able to get readings from the sensors, no problem. Everything is working, so we can head to the field. This will be the test in the field quickly of my saw doctor or engine doctor. So basically what we've got is battery, ESP32 thermocouple, and a BMP 280 temperature sensor, and temperature and no humidity on this one, temperature and pressure. So thermocouple, and we're just going to try it with the saw real quick. Let's see what happens. This will get a better case and better system in the near future, but for now this should allow us to see what's up and down. All right, we got Wi-Fi, so it sets itself up as its own Wi-Fi network called Engine Doctor. In this case, we're connected, no problem, it's working. Now we should be able to connect to the web page, 192.168.4.1, and in theory, we should have a web page. We're live and capturing samples. Check this out. So our temperature, it's nice and warm out. It's 25 Celsius out here. Atmospheric pressure, 984. And the thermocouple temp agrees with our BME 280. This is pretty awesome. I am pretty happy with this. Now what we can do is stick our thermocouple in and hopefully fire this thing up and see what we get. Now, this exhaust isn't the best one for this, so let's go through here for now, because this will eventually be mounted properly into the exhaust stream instead of just jamming it into the spark arrestor like we're doing here, which is not the best, but this will do just fine. Perfect, we're in. Now, awesome. We're up, back recording. I'm just gonna fire the saw up. I haven't had it running in a week, so it might be a little bit of a pain. Steady state, pretty good there. That seems to be idle. EGT for this saw is right about 200 Celsius. It's going to drop a little bit here as it reaches up and idles for a bit. Let's go to wide open. I am happy with that. That'll work just wonderful. You could tune off of that just precisely now. You can get the EGT dialed in just the way you want. This mixture is good and rich, and then we know where rich is, and then you could go a little bit leaner and see how hot it gets. I'm not concerned at that temperature at all. That's absolutely just fine. Because I know the saw is running good and rich on the high side and low. You can hear the burble there. Check out the video I'll link down below if you really want to see how I tuned this saw. And I've got other videos on how to set up a 2-cycle carburetor, but that is exactly what I wanted. I couldn't be happier with this. That is what I've wanted since I was a mechanic, since I was in the trade. An ability to see EGT easily on a device. Well, little did I know it would be a smartphone 20 years ago when I dreamed of this. And it is a reality. It's that simple. You can use this for any small engine, big engine, car, truck, anything, and have the results on the phone, which are recording right now. You could output to SD card. I broke out all the spare IOs on this. Well, I'll let future me narrate over this, but this is exactly what I wanted. I couldn't be happier. Man, oh man, that's perfect. I love it. Check out the coolest part of this. The saw is way over there, and we're still getting data packets way over here. What a perfect night to be testing this out. Well, we're here. Hey, let's do it. Let's do a range test. We're at about 15 feet there now, and let's go out a little bit and see where we start losing packets. I'm still screen recording here, so I'll try and dub the two together. Like, look at the distance there. This is perfect for saw competitions or something. If you had somebody helping you out, or any engine, anything, your pit crew can be quite a distance away and still catching data and reviewing data on the fly. Real live air temperature, real live pressure, atmospheric pressure. And if you use my BME 280 code for this, you can use humidity as well, which is another wonderful thing to know when you're tuning. But this is a long, long way away. Check this out. We're still getting packets. Still getting packets. Let's see. How far can we go? I've never range tested one of these ESP32s before. Now this is line of sight with no walls. Did we? Nope, we didn't stop yet. Holy smokes. Exhaust is nice, nicely cooling off. Holy, oh wow. We are a long way. I'm gonna start walking faster. Holy smokes. That's without an external antenna. This is getting crazy. Okay, I didn't expect this. I love real world testing. I'm almost to the limit of the property. I'm almost at the river. I'm gonna need a bigger boat. Okay, we finally dropped. Nope, yes. No, we just lost a packet. Maybe. Are we breaking up? There, we broke up. Nope. Oh, geez, I'm just gonna walk to the river. That's just the temperature reading fluctuating a little bit. Did we get it? Okay, there we go. We finally dropped connection. Here's our beautiful river, and way up there is our saw. That is absolutely crazy. I don't know what that distance is. That's a lot of meters. So yeah, line of sight, you can tune a long way. I'll let future me pick up the video here, but for the first real world field test of the final PCB, super happy. Totally open source. You guys can download it, have PCBWay, make your own. Cheers guys, this is great. I went ahead and updated the design in my Fusion 360 files. I wanted to add some text for my own branding, as well as the IP address for the web page to visit, because for some reason I just can't seem to remember that. So I figured if I embed the IP right into the lid, I'll always remember. Went ahead, designed it, printed it out on the i3 Mega. It came out great. All the files and information are linked below so you can print your own. This is actually the first case that I've used these bushings, these inserts in. It took a little bit of trial and error to get the hang of using my soldering iron to melt these down into the holes, but they fit perfectly. I'm really happy with the results. I think I'll use these on a lot more projects now that I've sort of got it a little bit figured out. It's a little bit of trial and error. As you can see, it's best to push down across the top and not insert the iron like I did. But once you get the hang of it, no problem. The end result is a modular system with a nice case and good protection for the components, good place to put a battery. I just wired the battery up direct. It has a charge circuit on the ESP32, and overall I'm pretty happy with the design. Final steps were just to add some vinyl lettering using my Cricut vinyl cutter. This really adds the final touches on a project. I found is to just have that labeling. It does take some time. It's a little finicky to do labels this small on the vinyl cutter, and I'm not really good at it, but the results are pretty cool. You just have to fight a little bit to make sure that your letters stick down, and at the end of it, this thing looks pretty pro. If you like these kind of projects, make sure you stop by the Discord link down below and join in for 24/7 live chat anytime you like. I've got these added to my store now. Also linked below, you can grab a kit with a PCB and all the components ready to go if that's what you're into, or you can just put the components together yourself and build your own on perf board or whatever. But the option's there if you like it. Hopefully you enjoyed this project. I know I sure did. It does exactly what I wanted it to do, and really happy with how it came out. And I wish I would have had this a lot of years ago. This will be pretty handy for tuning engines of all kinds, and also lots of other uses too. I couldn't be happier with the results.